All right, hello, my name is Mason Schaefer, and today we'll be doing Project 3 and on Fluent, and we will be, in this video, be doing Inviscid flow around a cylindrical uh, object. So first, what you want to do is start creating the geometry, make this in a 2D, and do new design modeler. Wait for that to open. Once this is here, we'll start to sketch a circle in the middle. Do dimensions, diameter. Make this 1 meter because it is specified for the project. Next, we will draw lines because we need to create a square around the when you make a square around the cylinder so it can demonstrate external flow. Start doing the dimensions. 1, 2. So make this 25, 25, and then draw another line up, another line down. Again, oh, dimensions, set the dimensions. Again, 25, 25. And now we'll draw our square around it. So just like this should be good. So now we can start deleting some things. So this and this, we're just going to delete. We'll delete, 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 and delete. And then we'll just draw another line just down from here. Then another line down from here. And then for concept from surface, just like that. Apply, generate, and yeah, should be the first step for this. So we can now close out of this. And now we'll go to the mesh. It may take a little bit. This open? All right. Oh, now that it's opened, we can start with our meshes. So first, we will insert and do a method mesh. Click the whole face, apply. We'll do triangles and I think that's all the same, right? That should be fine. Then we'll click generate and should look like this. Next, we will do an edge sizing. So we'll insert a sizing, then click this, apply, element size. We'll do number of divisions. We'll do 200 and then change the behavior to hard. Once that's done, we'll click generate. And now it should look like this somewhat. And then next, we'll be doing an inflammation mesh. So first, we'll apply this here. For a second, we'll apply this edge. And we will change it to first layer thickness. We'll define the height at 0.003. Do 100 layers. The growth rate of 1.05. And this should be hopefully good. All right, now that it looks like this, it's all right now, but we will need to change it because we want more elements. So with that, we want to make the element size as small as possible without crashing. So I had to test it and I got around 0.12 for my element size. We'll wait for this to go. All right, now that we're done, we can see it has a good amount of elements. So way better than before our mesh. So now we can go on to the next step. So we'll close this and we'll click generate, or sorry, update. And now I'm just gonna go over to my setup here because I have everything already done, but I'll still go through everything. So there's this. Takes a little bit. Wait for it to fully go. Oh, okay. Now it's done. You just click in setup. Uh, Double precision. Sorry, it should be already in 2D. And up your solvers if your PC allows for it. Let's load in. I did actually forget one thing. So we'll actually go back really quick to all this load. I'll go back really quick to show it. It takes a little bit to load. I okay. Let me go back to this really quick. I did forget to name everything. So I'll show you the names really quick. All right. Very, very simple. This will be called the inlet, outlet for this side. The top and bottom will be the symmetry. And then this will just be the wall. So now that's done, then you're officially done with the mesh or this mesh step. Just make sure you name everything. And now I'll just update it and then go back into my Fluent. It's a little bit to update. All right. Now that it's done, we'll go back to Fluent. And since this is Inviscid, you want to make sure you change the viscous to Inviscid. Very key because if you change to anything else, will probably not work properly. And yeah, make sure it's on Inviscid. Okay. Materials, fluid, make sure it's air. Sometimes it's different. Just make sure. Um, Make sure again, this is set to air. Apply, close. Now boundary conditions. So in this case, we were told to make the inlet velocity 5. So 5. And then everything else should basically stay the same. Just make sure everything else is at 0. Yep, 0. We're good. The wall, make sure it's stationary. Yep. Oh, well, actually, yeah, doesn't even move. In this symmetry, yep, everything's good. Um, Reference values, make sure inlet, make sure all this looks good. In my case, it does. Um, should be good. For this, the methods, this usually just looks better if you just do simple, least squares cell base, presto, and second order upwind. Controls, done. We'll do that after. Actually, we'll have to redo a lot because we have to. And then results, you can change residuals to whatever you want. I prefer just do 1e to the -6. And now we should be able to do the initialization. Everything else seems good. So yeah, we'll initialize, let that run, and then we'll then run the calculation. And usually the higher the iterations, the better, usually, if you want to be more accurate. But we'll let this run, maybe be a little bit. now that it's done, we can start looking at everything. So first we'll just do the contours, probably the easiest thing. First thing we have to do is find the pressure coefficient. So we'll save and display. And since it's Inviscid, the pressures should be, well, actually, in general, the pressure should be highest on the sides and lowest at the tops. Another contour we have to do is then the velocity one. So velocity and display. And again, it's actually just the opposite from the pressure one, lowest on the sides, highest at the tops. Um, we'll get this one out of the way. We'll do the drag coefficient next. I gotta find my reports. There you go. Forces, and just click wall, print, and that's our drag coefficient. I need to also another way to do this is to report definitions. You just click new, force, drag, then drag coefficient, wall, okay, and then um, you can just also just do compute, and bam, we got it right here. And then next is our graphs. First, we want the pressure one. So the wall. And for Inviscid, should look like this, just a big parabola. Perfect, like that. Um, and what you should do, since we want to, in this project, we want to put them all on one plot, you'll just click write to file, write. And then as you can see, you just write whatever you want, the Inviscid, and then save it. And I'll go through that whole process after, or in a couple of seconds actually. And then we have that, and we'll do another one for velocity, the wall, save, and again, kind of makes a parabola, well, upside down one. And that should be it for this that I remember. Nothing else. Just the two graphs, two things. Then next we will get the streamlines. So we're just gonna close this. Yes, that's fine. And then now we'll go to results. And to do the streamlines, I mean, I'll have it up already, but I'll redo it just because this is what it should look like. But all you'll do is click this streamline, and then all domains start from inlet 250, and yeah, looks like that. Basically the same. Oh, well, you could do also sampling, just do vertex. Yeah, change it to whatever you want. Looks basically the same, a little different, but still looks good for Inviscid. Um, and it once you did that write to file, you will, for both the pressure coefficient and the velocity, we'll close this out. You'll want to just find those. So in my case, mine was called Inviscid pressure coefficient. and you'll open it up and you'll get these values, and all you'll do is just you'll copy and all of them, and then go to Excel. I already have it plotted, but you'll literally just do this and then paste it. So that was for the pressure, and then you just find the Inviscid velocity, same thing. You just copy and then paste just like that. And I'll show it now. This is what the velocity should look like for Inviscid. Well, we'll be comparing them all, but yeah, look like that. And then the pressures look like that. And last but not least, I don't have it open. Uh, I don't have it open, but I'll open it up. And this will be my report for everything. This is what the Invisids will look like. And then the rest I'll show in the other vids. And velocity, pressure coefficient, here's the drag. And that will be it for this video. Thank you, and bye.